quadratic equations. We will be starting out with graphing quadratic functions without a calculator. We start with number 1 on your pretest, and it shows us that we have a equation in vertex form. We have a -2 inside of a parenthesis, which is going to be our x value, and we also have +0, which tells us that our y value of our vertex is not going to move. So remember, when it's on the inside of the parenthesis, we move the opposite. And so we are going to start here at 2, 0. This is going to be our vertex. And from there, we can create our table. And our x and y values, we start with 2. And then we go 1 above and 1 below, so 1 and 3. When we plug 1 in for x, we say 1 minus 2 is a -1, and when we square that, we get a +1. And when we multiply that by a -3, we get a -3. As we already said, we should have the 0.20, so let's plug in 2. So we have 2 minus 2, that is 0. 0 squared is still 0. 0 times -3 is still 0. So indeed, we still have that 0.2, 0. When we plug in 3 for x, we have 3 minus 2, which is 1. 1 squared is still 1. And then 1 times -3 is, again, -3. So we go to 1, -3, put a dot there. And 3, -3, put another dot there. And we have our upside down u. Fill that in a little bit there. Alright, looking at number 2. It doesn't look like it, but this is also in vertex form. Another way we could write this is y is equal to x plus 0 squared plus 6. If you were to FOIL that out, you'd end up with just x squared. Back with what we started with. So what we see here is that we have a vertex form. And again, that is our x and our y. So we're not going to change anything in x. We're going to go up 6 in y. 1, 2, 3, 4, 5, 6. Put a dot there. And again, create our table with 0 and 6, x and y. And we'll go -1, 1. So when x is a -1 and -1 squared is 1 plus 6 is going to be 7. 1 squared is still 1 plus 6 is again 7. We'll put a dot there and a dot there. And just for fun, maybe we'll put in a couple more points. We'll go a -2. -2 squared is 4 plus 6 is 10. And again, putting in 2, we'd get 10. Remember that through our vertex, we have a line of symmetry that is straight up and down. And that line of symmetry is always going to be equal to your x, the location of your vertex in the x direction. So as we plot these other 2 points, we have 2 and 10, -2 and 10, point there, and a +2 and 10, and a point there. And we have, again, our parabola. All right, looking at number 3, we have a equation that is not in vertex form. So what we want to do is we want to do that trick that we learned called completing the square, where we rewrite our equation, y equals x squared minus 4x plus 2, where we put in our parenthesis. Now we take our negative 4, we divide it by 2, and we square it. So over here I'm going to say negative 4 divided by 2 equals negative 2. And then we're going to square that, which is going to equal 4. So we're going to add 4 to the inside. Now because we're adding 4 to the inside, we can only add 0 to one side of the equation. So we added 4 to the inside of the parentheses, so we're going to subtract 4 on the outside. And we can factor this to x minus 2 squared, and then 2 minus 4 is negative 2. So now we have our equation in vertex form, and we have our x value here and a y value. So remember, the x is going to be opposite of what's inside there, so we're going to go positive 2 over and 2 down. Right there. So we have a negative 2x, y, and negative 2. So if we go negative 1, excuse me, this is going to be positive 2. So we go positive 1, 0, and then we go 3 and 4. We see that 1 minus 2 is a negative 1, and we square that. We're going to have a positive 1 minus 2 is, again, going to be a negative 1. When we have 0 minus 2, we have a negative 2. A negative 2 squared is positive 4. A positive 4 minus 2 is going to be 2. 3, we have 3 minus 2 is 1. 1 squared is still 1. Minus 2 is a negative 1 again. And plugging in the 4, 4 minus 2 is 2. 2 squared is 4. 4 minus 2 is 2. Again, we can always see that symmetry about our vertex. See, here we go 1 to the left, and we're at negative 1. So that means if we go 1 to the right, we should be at the same y value. We go 2 to the left at 2. If we go 2 to the right, we're at that same y value again. So we'll put our points on. Again, we have our parabola. Please do not worry about number 4, as this will not be on test. Okay. Alright, so now we're going to moving on to solving equations with our quadratic formula. Now, as we talked about earlier in the unit, there are more than one ways to solve these quadratic equations, but the surefire way is the quadratic formula. Even though the quadratic formula can solve every quadratic equation, it's not always the most efficient or the fastest way to get the solution. But again, I will show you how to use the quadratic formula, so at least we know the method that we can solve every quadratic equation with. Just a reminder, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, we have the plus and minus because we will be getting two answers or two solutions to these. So now as we rewrite this problem, we're going to subtract 11 from both sides. We end up with 6x squared minus 30 equals 0. Now again, looking at this is going to be our a. We have no b, and this is going to be our c. So a equals 6, b equals 0, c equals negative 30. Plugging all that into our quadratic formula, we see that we're going to have 0 plus or minus the square root of 0 squared minus 4ac. So we have 4 times 6 times 30. And this is all over 2a, which is 2 times 6. So as we simplify all that out, we have 4 times 6 is 24 times 30 is 720. But please be careful not to make the mistake I almost did right here. And again, that is a negative 30. So that's very important because we're going to have a negative number, right? A negative 720, but we're subtracting that negative 720, which is going to make it positive. Whenever we subtract a negative number, we're going to make that positive. So we have the square root of 720 over 12. Now as we look, the square root of 720 is equal to 26.8, and we're going to divide that by 12. We're going to get 2.23. Now again, this is plus or minus 2.23. So our answer, we should write it as x is equal to 2.23, and x is also equal to a negative 2.23. Now another way we could have solved that equation is instead of taking and putting everything into our quadratic formula, we could say that 6x squared minus 19 is equal to 11, and we're going to solve for x. So we're going to plus 19 on this side, plus 19 on this side, trying to get x by itself. So we have 6x squared is equal to 30. We're going to divide both sides by 6, again trying to get x by itself. So we're left with x squared is equal to 5. Now, to get rid of a square or a second power, we need to take the square root. But if we take the square root of one side, we need to take the square root of the other side. So when we take the square root of 5, we end up with the same thing. But again, when you take the square root, you can either have a positive or a negative. So x can be equal to 2.23, and x can also be equal to a negative 2.23. And if you're having trouble rationalizing why we get two answers when we take the square root of something, take a negative 2.23, square it, and you'll get 5. Take a positive 2.23, square it, and again you'll get 5. So that when x squared is equal to 5, you have two solutions. So on to number 6. Again, using the quadratic formula, we'll get everything on the one side of the equation, set it equal to 0. So we're going to subtract 44. So we have 4x squared plus 156 is equal to 0. Again, a is equal to 4, b is equal to 0, and c is equal to 156. Plugging everything into our quadratic equation, b is 0 again, plus or minus the square root of b squared, which is again 0, minus 4AC. So we have 4 times 4 times 156. And this is all over 8. Well, what we're going to see here is that 0 plus or minus the square root of 4 times 4 times 156 is equal to 2,496. But we are subtracting that. That's all divided by 8. Now this is a big reminder. We need to look at this part right here. We cannot take the square root of a negative number. We cannot multiply two of the same thing together and ever have a negative. Okay? So this has no solution. As we look at number 7 here, we are going to have to factor this one out, or excuse me, FOIL this one out to get it to a workable quadratic equation for us to use our quadratic formula. So we take x plus 3 times x plus 3, because it's to the second power, right? So we're going to times whatever is in these parentheses by itself to the 36. So as I FOIL this out, remember the first, x times x is x squared, plus the outside, x times 3 is 3x, times the inside, 3 times x is, again, 3x, and our last, 3 times 3 is 9. Set that still equal to 36. Now we're going to combine the like terms. We'll subtract 36 from both sides. And we have with x squared, combine our like terms, we're going to have x squared plus 6x, 9 minus 36, going to be a negative 27, is equal to 0. Negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times negative 27, all over 2. So we have a negative 6 over 2 plus 4 times negative 27 is negative 108, but when we subtract a negative 108, we need to add it. So 36 plus 108 is going to be square root of 144 over 2. So that is our plus. Now we need to take our minus. Negative 6 over 2 minus the square root of 144 over 2. And we will see that the square root of 144 is 12. So negative 6 divided by 2 is 3, plus 12 divided by 2, so negative 3 plus 6 is positive 3. And here we have a negative 3 minus 6, which is going to be equal to negative 9. So x can be equal to 3 and x can be equal to negative 9. Looking at just the equation, a different way to solve it would be x plus 3 squared equals 36. Now we can take the square root right away. Now the square root of 36 is plus or minus 6, so x plus 3 is equal to plus or minus 6. So when we split that up into two equations, we say x plus 3 equals 6 and x plus 3 equals negative 6. Well, in this instance, we're going to subtract 3 from both sides, and we're going to end up with x equals negative 9. We'll subtract 3 from both sides here, and we'll end up with x equals positive 3. Again, we got to the same spot, just using 2 different methods. So if you're comfortable with using this method, it's obviously a lot shorter, but again, the quadratic formula will still work. So here it looks like they're going to introduce a b to us here again. We don't have a whole lot of manipulating. We just have to get that 9x over on the left-hand side. So our a equals 2, b equals negative 9, c equals negative 8. And we plug it into our formula. So negative 9, the negative of a negative 9 is positive, plus or minus the square root of b squared, which is 81, minus 4ac, minus 4 times 2 times negative 8, all over 4. So when we have 4 times 2 times negative 8, that's going to be a negative 64. So 81 minus a negative 64 equals 145. So we have 9 over 4 plus the square root of 145 over 4. And with 9 over 4 minus the square root of 145 over 4. Now the square root of 145 is 12.04. So we'll have 9 over 4 plus 12.04 divided by 4. And this is going to equal 5.26. We're going to have subtract it. And we get a negative 0.76. This one here, there is no other way but using the quadratic formula to solve that one. Okay, so number 9, we do not have a C, we have A equals 15. Don't be confused about these two being flipped around. They just didn't put it in standard form. B is equal to 5, C is equal to 0. So we say negative 5 plus or minus the square root of 25 minus 4 times 15 times 0. This is all over 30. So as we simplify that out, we have a negative 5 over 30 plus, now this is going to all go to 0 because we're multiplying by 0. So we just have the square root of 25, which again is 5. So we have 5 over 30. And we have a negative 5 over 30 minus 5 over 30. This is going to be equal to 0. This is going to be equal to a negative 10 over 30 or negative 0.333. Repeating. For number 10, we have A is equal to 1, B is equal to 7, C is equal to 10. we have a negative 7. Again, we have negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times 1 times 10 all over 2. So we have negative 7 over 2 plus square root of now 49 minus 40 is going to be 9 over 2. We have a negative 7 over 2 minus square root of 9 over 2. This is going to equal negative 7 divided by 2 plus the square root of 9 divided by 2. This is going to be a negative 2. And we have a negative 7 over 2 minus the square root of 9 over 2. And that's going to be equal to negative 5. Now again, we can solve this a different way. We can see that x squared plus 7x plus 10 is equal to 0. We know that we can factor that by putting in our x, putting in our 10. 2 times 5 is equal to 10, and add together is going to get 7. So we have x plus 2 times x plus 5 is equal to 0. And what you do is you just set each one of those equations equal to 0. So x plus 2 equals 0, and x plus 5 is equal to 0. And you just solve for x. So you subtract 2, subtract 2, subtract 5, subtract 5. This is going to be negative 2, and this is going to be negative 5. Again, same thing. All right, marching right along here. We have a is equal to 2, b is equal to negative 5, c is equal to negative 12. So the negative of negative 5 is positive 5 plus or minus the square root of negative 5 squared is 25 minus 4 times 2 times negative 12. This is all over 4. So we have 5 over 4 plus square root of 4 times 2 is 8 times the negative 12 is a negative 96. So 25 subtract a negative 96 is 121. That is divided by 4. And we do the same thing, except we subtract the square root of 121 over 4. Now the square root of 121 is 11. And so this is the same as 5 over 4 plus 11 over 4. This is 5 over 4 minus 11 over 4. And this is equal to 4. And this is equal to negative 1.5. Number 12. Here we just got to get 6 over the other side, so we're going to subtract 6x from both sides. rewrite the equation. X squared minus 6x minus 27 is equal to 0. Now we're going to use the quadratic formula. A is equal to 1. B is equal to negative 6. C is equal to negative 27. Plugging that in, we have the negative of a negative 6 is 6, plus or minus the square root of b squared, which is 36, minus 4 times 1 times negative 27, all over 2. So we have 6 over 2 plus 4 times 27 is 108. 36 minus the negative 108 is 144. All over 2. And we have 6 over 2 minus the square root of 144 over 2. Now the square root of 144 is 12, so we have 6 over 2, which is 3, plus 12 over 2, which is 6. That's going to be 9. And then we have 6 over 2, which again is 3, minus, this is 2. 12 over 2, which is 6. So 3 minus 6 is negative 3. Now again, we could achieve that answer by factoring. X squared minus 6x minus 27 is equal to 0. That is the same as x minus 9 and x plus 3. Set each one of those equal to 0. And you'll see that you'll come up with the same answers of 9 and negative 3, as we saw for x right there. All right, number 13. We'll get everything on the one side of the equation again. We have 8x squared minus 6x is equal to 0. A is equal to 8. B is equal to 6. C is equal to 0. That is a negative 6. So we have 6 plus or minus the square root of 36 minus 4 times 8 times 0 all over 16. So we have 6 over 16 plus, again, we have 4 times 8 times 0, so that's going to be 0. Square root of 36 is 6, so 6 over 16. And we have 6 over 16 minus 6 over 16. This is going to be 0, and this is going to be 0.75. All right. Here we have 3x squared plus 5x plus 1. A is equal to 3. B is equal to 5. C is equal to 1. So we have a negative 5 plus or minus the square root of 25 minus 4 times A, which is 3, times C, which is 1, all over 2A, which is going to be 6. So negative 5 over 6 plus 25 minus 12, which will be the square root of 13 over 6, and we have a negative 5 over 6 minus the square root of 13 over 6. So calculating this one out, we get a negative 0.232. And here we'll get negative 0.6 minus 5. Negative 1.44. Okay, so that is using the quadratic formula or other methods. A big portion of your test, hopefully. If there's any questions on that Monday, please let me know right away. Alright, so now what we're going to do now is we are going to take a quadratic equation and we're going to apply it to a somewhat a real life example. Here we have Acme Pools is building rectangular wading pool. The area of the bottom needs to be 70 feet squared. So as we look at a swimming pool, okay, we have this bottom section here needs to be 70 square feet. Now, to get the length, we would call this x. And so we would set 70 in for a, because that's what we want to figure out. What should the length of the pool be? So we say that 70 is equal to x squared plus 3x. Now again, we can just change this into a standard quadratic equation, apply the quadratic formula. So we have x squared plus 3x minus 70 is equal to 0. We set a is equal to 1, b is equal to 3, c is equal to negative 70. Plugging that all into our equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. We see that we have a negative 3 plus square root of b squared, which is 9, minus 4ac, which is going to be 4 times 1 times negative 70. All over 2. So negative 3 over 2. Excuse me, this is plus or minus. So negative 3 over 2 plus, that's going to be a positive, or we have 4 times negative 70, which is going to be a negative 280. So 9 subtract negative 280 is going to be 289. By 2. And we're also going to have negative 3 over 2 minus the square root of 289 over 2. This is going to be equal to negative 10. Oh, excuse me. This over here is going to be equal to negative 10. And this over here is going to be equal to 7. Now, because we're looking for, again, the length of a pool, our length cannot be negative. So it has to be 7, and that is our answer. So our looks like the length of our side will be 7 feet. So number 16, an acorn falls 45 feet from the top of a tree. So when it says top of a tree at 45 feet, that should tell us something. So when, again, as we look at a quadratic equation, right, we know that we have a vertex, which is either the highest point or we have a vertex which could be the lowest point. So because it's from the top of the tree, we're probably going to be looking at the highest point. The height h of the acorn at time t is h is equal to a negative 16t squared plus 45. How long will the acorn take to hit the ground? So again, we're talking about the ground. So the height above the ground when you're at the ground is going to be 0. So at the ground, h is equal to 0. So we just say 0 is equal to a negative 16t squared plus 45. Now again, you can use your quadratic formula up here where a is going to be equal to 16, a negative 16. B is going to be equal to 0. C is going to be equal to 45. Or we can say that we can move this equation around some. We can say that 16t squared is equal to 45 divided by 16 on both sides. And we see that t squared is going to be equal to 45 divided by 16, which is 2.81. Take the square root of that. So the square root of 2.81 so t is equal to plus or minus 1.67 seconds. Now, unless you can go back in time, you're not going to have negative time. So our answer we know is positive 1.67 seconds. Number 17. It looks like a lot like 16. A falcon dives towards a pigeon on the ground. The height h of the falcon at time t is h equals a negative 16t squared minus 220t plus 100. Estimate the time the pigeon has to escape. So, again, the pigeon is on the ground. So our h is going to be equal to 0. So we set 0 is equal to a negative 16t squared minus 220t plus 100. Now we're not going to be able to use that trick that we did on 16, so we have to use the quadratic formula where a is equal to a negative 16, b is equal to a negative 220, c is equal to 100. So we have a negative 220, excuse me, that's going to be positive because of negative b. So the negative of a negative is positive. Plus or minus the square root of 220 squared is equal to 48,400 minus 4 times negative 16 times 100. This is all over negative 32. So as we simplify this, we have 4 times 16 is going to be 64 times 100. We're going to have a negative 6,400, but we're subtracting that, so we're going to actually be adding it. So underneath the square root sign, we're going to have 54,800. So we have 220 plus the square root of 54,800 all over negative 36. And we're going to have 220 minus the square root of 54,800 all over a negative 36. And the square root of 54,800 is 234. So we have 220 plus 234 divided by negative 36. And this is going to be equal to a negative 12.61. Again, we're looking for time, and time is not going to be negative for us, so we know that's not going to be answered. So hopefully this one comes out positive, so we'll see what happens. So we have 220 minus the square root of 54,800. We're going to divide that by negative 36. And this is going to be equal to 0.39 seconds. So that pigeon has less than a second to escape. Not very much time. The hawk's probably going to have some dinner. Alright, so now we're going to create a quadratic model from our data. Now, our standard form for a quadratic equation in vertex form is going to be y is equal to a times the quantity of x minus h squared plus k. Now again, h is going to control our vertex from left to right in the x direction, and k is going to control it up and down. So what I'm going to do here is I'm going to come across and see if I can find a high point or a low point. And it looks like 18 is my highest. Then it goes down to 8, then to 0, to negative 6, to negative 10, negative 12, negative 12, back up. So here we're going down, down, and here we're going back up. So it looks like we have a low point somewhere in here. But my issue here is that I have 2 points that are the lowest. So it looks like I have something going on here that at between 1 and 2, I have 2 points. And we're getting higher over here, we're getting higher over here, but we don't know what's happening in between there. So we can assume, right, that we have one lowest point. So we're going to say that that lowest point is at right in between 1 and 2. We're going to call it 1.5. So y is equal to a times x minus, now again we have to do the opposite, so I just caught myself, 1.5 squared. Now it looks like, we can't have our vertex at negative 12 because that point has to be lower than that. So we'll just say it's at negative 12 point, we'll say 5. Okay? But we still have this a right here. And the way we take care of the a is we take any point from our table and we plug it in for x, and we plug it in for y, and then we solve for a. So I'm going to pick a point with a 0 in it. So I'm going to pick this point right here. Negative 2 and 0. So y is equal to 0. So 0 is equal to a times x, which is a negative 2, plus 1.5 squared minus 12.5. So negative 2 plus 1.5 is going to be a negative 0.5. And when we square that negative 0.5, we're going to have a negative 0.25. We are going to add this to both sides. Oh, I see an issue here. The issue I made was our vertex was to the right, and I did not put the opposite. So this right here should be negative, and that's causing me trouble. So I'm going to go in there, I'm going to erase all that. And we'll try it again. Minus. All right. Again, we'll use the same point of 0 equals a times negative 2 minus 1.5 squared minus 12.5. Negative 2 minus 1.5 is 3.5. And when I square that, I get a negative 12. Excuse me, I get 12.25. So a times 12.25 minus 12.5 is equal to 0. We're going to add 12.5 on both sides. And we end up with 12.5 is equal to a times 12.25. Divide that on both sides. And we end up with a is equal to 1.02. And I think what happened here is that our number here is just a little bit off. But that's okay. On your test on Monday, what I'm going to be looking for, does your vertex make sense, and then your work to how you got A. So again, as I show this work, I would just write as my final equation, y is equal to Now I bring up my A, 1.02, and then I just bring over what I have here, times x minus 1.5 squared minus 12.5. Okay? And that is your equation that will give you somewhere around those data points. All right, using the discriminant. The discriminant is just that part of the quadratic formula, which is the b squared minus 4ac. And just a reminder, when this is less than 0, we have no solution. When b squared minus 4ac is greater than 0, we have two solutions. And when b squared minus 4ac, let me rewrite that, is equal to 0, we have one solution. So let's take a look at number 19. B squared, again, this is going to be A, this is going to be B, this is going to be C. So B squared, which is negative 3 squared, is going to be 9 minus 4AC, which is going to be 4 times 3 times 4. 4 times 3 is 12, times 4 is 48. So 9 minus 48 is going to be a negative 39. So we have an answer that is less than 0. So we have 0 solutions. Here we have A, B, and C. So we have b squared, which is going to be 4. Negative 2 squared is 4 minus 4 times negative 1. So we have 4 times 4, which is 16, times negative 1 is a negative 16. But we're subtracting, so 4 minus a negative 16 is going to be equal to 20, which is greater than 0. So we have two solutions. So here we want to see the graph of y equals a negative 0.2x squared plus 3.5x minus 20 miles, the height of one of the arches at the entrance to a park structure. Can a truck that is 20 feet high fit under the arch? So we can go at this a couple different ways. One is we can say, plug this into our discriminant, and so we have 3.5 squared minus 4 times a negative 0.2 times a negative 20. So we're going to see here that 3.5 squared is 12.25 minus negative 4 times negative 0.2 times negative 20 is positive 16, so minus 16. This is going to be equal to a negative 3.75. So we have no solutions, which means that this equation either looks like that or looks like that, but either way, it is not touching our x-axis, so we're not driving any trucks through a structure that's not touching that x-axis. So that would be no solution or no. All right, back to Unit 8. Unit 8 review. Here we're just combining our like terms. Again, we're going to distribute this negative. So we have 2x squared minus 7x squared, so that's going to be negative 5x squared. We don't have any x's in this one over here, so that's just minus 3x. And we have 8 minus a negative 4. So when we minus a negative 4, we're going to add 4. Right? So that's going to be plus 12. So give an example of a cubic binomial. So cubic means that we have a degree of 3. So we have x to the third. Binomial means we have two terms. So plus 3 could be 3x, could be 3x squared, could just be 3. It says state your leading coefficient of your polynomial. So this is my leading coefficient right here. I didn't have anything there, but really that's just a 1. So my leading coefficient is equal to 1. So here we're going to multiply the polynomials. So remember, I have to distribute my x in all three places. I also have to distribute my 2. All three places. So x times 2x squared is 2x to the third. X times 3x is plus 3x squared. X times negative 4 is minus 4x. Now for my 2, I have negative 2 negative 2 multiplied by 2x squared is negative 4x squared. Negative 2 times 3x is negative 6x. Negative 2 times negative 4 is positive 8. And now we're just going to combine the like terms. 2x to the third minus x squared minus 10x plus 8. And that is our solution to that one. Number 25, factor completely. So whenever it says factor completely, that's something to watch out for. We're probably going to have to take our greatest common factor, or GCF, and then factor. So now I'm going to look for my greatest common factor. It looks like I have a 2 here, I'm going to have a 2 here, I'm going to have a 2 here. I have an x here, an x there, an x there. So let me start with 2x. I'm going to divide each one by 2x. So 2x to the third divided by 2x is x squared. 10x squared divided by 2x is going to be 5x. Negative 48x divided by 2x is going to be minus 24. Okay, so now what I have to look out for, can I factor what is left inside here? So I'm going to make my x. What goes in the bottom? My negative 24. What goes in the top? My 5. So what two numbers can multiply together to get negative 24 that add up to get 5? So I have 6 and 4 multiplied to get to 24, 12 and 2, 1 and 24, and 3 and 8. Well, 3 and 8, that's close to adding together to get to 5, or exactly on. So if I say 8 and negative 3, negative 3 times 8 is a negative 24, and 8 minus 3 is 5, so I think we have a winner there. We have 2x, we have x plus 8, and x minus 3. And there we go. Unit 7 review. 26, remember we have to distribute our exponent as outside parenthesis. Now each one of these units in here, remember, has an exponent of 1. So we have 2 to the third, a to the third, b to the third. This is going to be multiplied by negative 4 squared. Now we'll just do the same to this 2. So we have 2 and 2, right? So negative 4 squared. And then we have a squared. So 2 to the third power is 8. Combine my a's, that would be a to the fifth, b to the third still. This is multiply. Negative 4 squared is going to be 16. Now I can combine my 8 and my 16 to 128. And that is my final answer. So here what we have to look for, those no negative exponents. So looks like we have a couple of negative exponents here, but the way I'm going to do this is I'm going to I'm going to distribute my exponent in. So again, negative 5 times negative 8 is positive 40. So m to the 40th power. 7 times negative 5 is n to the negative 35. 4 times negative 5 is negative 20. Now, I have negative exponents and I need to get rid of those. So what do? I take those across my border, and whenever they go across the border, they just change their sign, right? So m to the 40th over n to the 35, p to the 20th. Again, the only reason I brought those across the board is they were negative, and I wanted to make those ones positive. All right, so number 28. I'm going to do this one a little bit differently. I'm going to simplify within my parenthesis first. So I still have this to the 5th. I'm going to bring my negative 2 up. So I have x to the 9th, x to the 2nd. I'm going to bring my negative 7 down, y to the 7, y to the 3rd. Okay? And then I'm going to simplify that even more. I'm going to combine my x's and my y's. So I have x to the 11th over y to the 10th. And now I'll distribute my 5. Now remember, not only do I distribute to the top one, but I also have to distribute to the bottom one. So we have x to the 55 power over y to the 50th power. And that is my answer there. For some reason, when I transferred this in, my graph didn't show up, so I'll just create a quick graph for each one of these. So as I look at A, it says y is equal to 3x. So I know that I'm going to increase at a very steep rate, and this is A. For B, I have this 4 here, so that means that I start off at 4. So 1, 2, 3, 4, but I still increase at the same rate. So this is B. C, I'm actually getting smaller. So I start back here and I come down. Again, that is because my common ratio here is 3. My common ratio here is 3. My common ratio here is 0.3. 0.3 is less than 1, so I am multiplying every time by something that is less than 1. Whenever you're multiplying by less than 1, it's kind of like dividing, so you're going to keep on getting smaller and smaller and smaller, as you see right here. D is just a linear equation, so this is, our old y equals mx plus b. This is our slope. This is our y-intercept. So we go up 4, and then we go up 3 and over 1. 1, 2, 3. That's about as straight as line as I can draw, but this is D. Unit 6. So we are graphing absolute value. How do I know this is absolute value? Because I have these straight bars here on this side. And what does an absolute value do? An absolute value takes something that's negative and makes it positive, and it takes a positive number and it keeps it positive. So here, it's kind of like when we look at our vertex form. Whatever's inside here is going to move our vertex to the left or right, and whatever's outside here is going to move it up and down. And remember, what an absolute value graph looks like is a V, either that way or that way. So when it's inside the bars of the absolute value, I have to move it to the opposite of which way it's telling me. So that says positive 3, so I have to move it negative 3. And this number right here is going to be my slope of my lines, the slope of my v. So I need to go down 2 over 1, down 2 over 1. Just keep on doing that. And there is my v. Oops. All right, so let's check this point right here, which looks like -1, comma, -4. So as I put in -1 and -4 for my x and my y, do I come up with a true statement? So I have a -4 is equal to -2 times the absolute value of a -1 plus 3. So -1 plus 3 is 2. The absolute value of 2 is still 2. 2 times -2 is -4. So that looks like that is a good point. If you'd like, you can check other points. Number 31. What will be the vertex of the graph with the equation y equals the absolute value of x minus 4 and plus 7? Now again, when it's inside the absolute value bars, we need to take the opposite. So our vertex is going to be equal to, or it's going to be at point 4, comma 7. All right, on 32, we're going to solve for x. And we have, first thing we want to do is we want to get what's in right here by itself. So in order to do that, we need to divide by -4 on both sides. So we have absolute value of x plus 2 is equal to 4. -16 divided by -4 is 4. And because of absolute value, we always will have two answers that will satisfy our x to make this statement true. So the way we handle that is we say that x plus 2 is equal to 4. We set up two mini equations. So this is our first one, then our other one is going to be x plus 2 is equal to a -4. And now we just solve for x. And over here is x is going to be equal to 2. Over here is x is going to be equal to a -6. And to check our answer, what do? We can take our -6, plug it back in, or our 2 and plug it back in, and see what we get. 33, we're going to solve and graph, and that's kind of like what we just did. We're going to create two different equations. One is going to be that x plus 3 is less than 2. And then we also have to say that x plus 3 is greater than a -2. Again, now we get x by itself. So we say, put a big circle at -5, then an open circle at -1. And because x is greater than -5, I know that everything this way from 5 is going to be good. But x is also less than -1, so everything this way from -1 is going to be good. So the numbers in between here is what make this equation true. All right, so that is the end of our slideshow. Hopefully that helped. Again, if there's any extra questions on Monday, we'll address those. And good luck on your test.